Welcome to Genius Panda Virtual Labs, where students and teachers access the virtual laboratory simulations for various science subjects.
Hello learners, welcome back. In this lesson, we will learn the polarity of molecules. It's the second part of the polarity of molecules simulation, and the first part has been explained in another video. It involves the polarity of bonds. As we said, polarity of bonds is a very necessary concept. We said that to understand polarity of molecules, we need two things: bond polarity understanding and molecular geometry. This polarity of molecules is found in Unit 4, Covalent Bonding and Molecular Geometry of Chemistry Senior 4, according to Rwanda Education Board. Here we have the objectives of our lesson. Polarity of molecules, and here we have the objectives of our lesson. At the end of this lesson, you should be able to identify polar and non-polar molecules, explain why some molecules are polar while others are not, and explain why a molecule is non-polar while its bonds are polar. Of course, you should also be able to show this using the lab simulation. What are the prerequisites to know required? What are the prerequisites required to understand better this video, this lesson? What are the necessary prerequisites to better understand this lesson? To better understand the lesson, we should have a clear understanding of molecular shapes and bond polarity. I said that. And the videos explaining these concepts, the concept of molecular shapes and the concept of bond polarity, have been explained. You can find them on the platform www.opanda.xyz. Polarity of molecules. Molecular polarity depends on two things: the relative electronegativities of the atoms in the molecule and the shape of that molecule. The relative electronegativities of the atoms in the molecule will govern the polarity of bonds. So we should focus on two things: polarity of bonds and shape of the molecule. Here we have some common shapes: linear shape, the angular shape, trigonoplanar shape. We have some common shapes here. The dipole moment and the polarity. The polarity of a molecule is determined by measuring the dipole moment of that molecule. And what is a dipole moment? Dipole moment occurs when two electrical charges of opposite signs are separated by a distance. Suppose that we have two charges. Suppose that we have two charges, a positive charge and a negative charge, separated by a distance. In this case, we can get a dipole moment. Why? Because we have two charges separated by a certain distance. Okay? The dipole moments arise from differences in electronegativity. Here we are focusing on the bonds. The dipole moment of a bond will arise from the differences in electronegativities of the atoms making the bond. If the two atoms are different, they have different electronegativities, then they will have different charges. You remember the polarity of molecules. You remember the polarity of a bond. The more electronegative atom gets a partial negative charge, and the less electronegative atom gets a partial positive charge. So because we have a partial negative charge and a partial positive charge separated by a certain distance, we get a bond dipole, or a dipole moment of the bond. So the larger the difference in electronegativity, the larger the dipole moment. Molecules which do not contain polar bonds are nonpolar automatically. If the bonds are nonpolar, then the molecule is automatically nonpolar. The molecule will only be polar if it contains some polar bonds, and which will give a dipole moment of the molecule, which is not zero. Molecules that contain polar covalent bonds will not be polar if the dipole moment vectors on each molecule cancel each other out. This is seen when a molecule is completely symmetrical. You can use the example here. I will explain this. A molecule containing polar bonds can only be polar if the structure of that molecule is not symmetrical. Let's have these examples and we explain. You see, we have carbon and oxygen. We have two bonds on this side. There is a dipole, the bond dipole, because oxygen is more electronegative. It is pulling electrons from carbon. So we have this dipole. We have another dipole here. And the two dipoles are moving in opposite directions, and they are of the same magnitude. So because of being of the same magnitude and moving in opposite sides, they cancel out. And as they cancel out, we get a molecule which is non-polar, even though the bonds are polar. So the net dipole moment of this molecule is zero. So the molecule is non-polar. You get it? And that is because the molecule is symmetrical. The molecule is symmetrical, carbon, oxygen, oxygen. We can get a center of symmetry on this side. On this side, we have the same thing. Okay? Now let's have a look at this, the distribution of the charges. Look at the shape. Here we have the linear shape, but here we have a bent shape. What will be the center of the charges of the hydrogen, the partial charges on hydrogen and hydrogen? The center will be here. And the center on the oxygen is, let's say it's here. So what do we have? From this, we have a positive center and a negative center, showing that in our molecule, we have two charges which are separated by a distance. Being separated by a distance means that we will get a net dipole moment of our molecule, which is not zero, and our molecule, of course, will be polar. But the first thing, as we said, the bonds should be polar. And you can see we have oxygen, hydrogen, the bond is polar with a bond dipole and with a bond dipole. But this time, because our molecule is not symmetrical, what we have is that the dipole moments, they are pointing in one direction. They are not moving in opposite directions. And because of that, we get a net dipole. So the dipole, you can see the molecular dipole, which is here, showing which is what is different from what we have here. Okay, so our molecule of water is polar because it has a net dipole moment, which is different from zero. Remember, it's because we have polar bonds and the bond dipoles are not canceling out. Okay, The simple definition of whether a complex molecule is polar or not depends upon whether its overall centers of positive and negative charges overlap. If the center of positive charges and the center of negative charges do overlap, then the bond dipoles will cancel out. But if they do not, they will not cancel out, making our molecule polar. We have some common molecules which are automatically nonpolar if the atoms joined to the central atom are all the same. Molecules with a shape of a linear shape, trigonoplanar shape, tetrahedral, trigonobipyramidal, octahedral, all of these shapes, they automatically are nonpolar if these atoms joined to the central atom are of the same element. We have other examples here. The molecule we have here is nonpolar. However, you can see the bonds are polar. Why is it like this? It's because due to the dipole moments, we will cancel out the bond dipoles, which will cancel out this molecule being symmetrical. Being symmetrical, it has dipole moments which will cancel out, then the net dipole of the molecule will be 0. Okay, so they are all like this. So because our molecule is symmetrical, the bond dipoles will cancel out, or simply the center of the positive charges will coincide with the center of the negative charge, and because of that, they will cancel out, making our molecule nonpolar. We have the same shape, tetrahedral, but you can see there is something different. We have a different atom here, a different atom which gives a different bond dipole. So these ones will coincide. The center of the center of the positive charges may coincide, will not coincide, of course, with the center of the negative charges. You can see the negative is here and the center will be somewhere here. But because even you can see the center of the negative is here on chlorine, and for carbon, it will be here. So we have two charges which are separated by a distance, giving us a net dipole, which is not 0, the molecular dipole, and then our molecule becomes polar. Now, let's go to the simulation and see how it can be used to explain the polarity of molecules. You can restart. This is how it looks. Here we have the molecular dipole, we have the bond dipole. Remember, here we have two atoms. We used this to explain in the previous video to explain bond polarity. Now we use 3 atoms to explain polarity of molecules. You see, we have atoms, 3 atoms, which have different electronegativity values, but you can set the electronegativity values to the same value if you want. And because they are of the same electronegativity, you can see you don't even have partial charges, you don't have bond dipoles, and the molecular dipole is 0. So your molecule, regardless of the shape, it is nonpolar. You can change the shape, let us make it linear, doesn't change anything. You can also put there the electric field. There is no effect of the electric field. Why? Because we have bonds which are nonpolar. When the bonds are nonpolar, automatically the molecule becomes nonpolar. Let's look if we increase the electronegativity of the central atom. We have increased the electronegativity of the central atom. What happens? Because the central atom is more electronegative, now it has a partial negative charge. Partial positive charge on the surrounding atoms. And here we have the dipole moments of the bonds, or the bond dipoles. The bond dipoles which are moving in opposite directions. Remember, we said that if they move in opposite directions, what do we get? We get, you can see the molecular dipole. The molecular dipole is 0. And that is why the molecule is like swinging in the electric field. It's like swinging in the electric field. Okay? Now let's have a look at what happens when you increase. Let's decrease this one and increase the electronegativity of this molecule. We increase the electronegativity of this atom, atom A. What happens? Okay. Atom B has a partial positive charge, but this one has no charge. Why? Because the bond is between B and C, and they are of the same electronegativities. But this one is partially negative because it is more electronegative than B. And we get a bond dipole moving from B to A. And even the molecular dipole, it is from B to A. And in the electric field, this is what we get. The partial negative pole moves towards the positive plate of our electric field. Okay? What happens if we change the shape? Changing the shape will always bring back the negative pole to the positive plate, or will always point the molecular dipole to the positive point. Remember, the dipole moment moves from the positive pole to the negative pole. It's always like that. The pulling force is always in the direction of the positive, which is almost losing, and the negative, which is almost gaining. So it is always pointed to the positive plate of the electric field because it is moving from the positive to the negative. Now let us reset and see what happens. We have B, which is more electronegative with the molecular dipole here. You can rotate the molecule, you can rotate the atoms, you can do anything. And you can show the bond dipoles, okay? You can change the electronegativity value and see as the electronegativity value of atom B decreases, the bond dipoles are also decreasing, and even the molecular dipole is also decreasing towards making the molecule neutral. Finally, it becomes neutral, okay? You increase, the molecular dipole also increases, and even the bond dipole will increase. And even the charges, by the way, when you show the charges, they are also becoming larger. When you show what happens when you reduce the electronegativity, they are becoming smaller and smaller. Okay? When it increases, they become larger. In the electric field, guess what will happen? We said this one will always point towards the positive pole of the electric field. Exactly, that is what is happening. Okay? So, in brief, that is what happens, and that is how we can use this simulation to show how some molecules will be polar while others will be non-polar. Remember, if a molecule has non-polar bonds, let's set it to the same electronegativity. We set it to the same electronegativity like this. It's better and easier. Regardless of the shape, the molecule becomes polar. Regardless of the shape, the molecule is non-polar. Why? Because the bonds are non-polar. And now, if the bonds are polar, what happens? This now will depend on the shape. That is what we say. If the shape is linear, what happens? Now we have polar bonds, but the molecule is non-polar. You can see that it is not pointing towards the positive plate of the electric field. So the two important things you have to always remember is that the polarity of a molecule depends on the shape and the nature of the bonding. Okay? How is this polarity of molecules useful in our everyday life? Or how does it influence the physical properties of some compounds? Some compounds, for example, water, they have high melting points. And that is because of the polarity of that molecule. For example, if you boil water, you can see that it boils at a higher temperature than what one could expect. One of the reasons is having or being polar, a polar molecule. You remember this solubility of substances. We know that some substances are soluble in polar solvents, while other substances are not. We know the use of soaps, for example. The soap can work because it can dissolve some polar substances. Actually, it has two parts. The soap has two parts. A part which can dissolve oil and a part which can dissolve water or which can be soluble in water. So that is how it works. It dissolves that and can be washed away with water because of the affinity it has with both substances, the polar and the non-polar. So the polarity of molecules is a concept which is very useful in chemistry and which is very important in determining the properties of substances, like solubility, the physical state, the intermolecular forces, the boiling point. Okay? I hope you have understood. Now let's go to the quiz. Here is the code for our quiz. And let me remind you one thing, if you have not really understood what means molecular polarity, the bond polarity, you can watch and watch again the videos, and when you feel confident, you can take the quiz. The code is VIB 001016, and you go to opanda.xyz, you click on login, and then on take a quiz, and after that, you type the quiz code here, and then you take your test. I hope you enjoyed, and you will be there for more videos. Thank you very much. See you soon.